Alright, so for my ternary abacus here, algebraic abacus, because it can handle equations, I built a base, and I've come up with some names for things because things need names, right? So the whole thing, I decided to call that a Samgan. So that there's a few things going on there. One, that sounds like swanpan, which is a very similar sort of abacus, in a sense. But Sam is like sort of the Pan-Asian, perhaps Korean specifically, term for three, and we're using balanced ternary here, so that makes sense. Gan, it's kind of a pun because it can mean like the Greek term, right? Like pentagon, right? Like sides. So we're using different sides of this, three different sides of this. So it's like three sides, or gan like hogan for house in the ne. So there's a little bit of a pun going on there. Each one of these little pieces, I decided to call it tun. Again, there's some puns going on there. It's a nut, so that's nut spelled backwards. But it's also a northern hemisphere word for like a stone or a heavy object, right? The English word stone, that's actually the root, and the English measurement ton is the same, and like Mayan word for rock is tun, it's the same thing. So it's like the heavy object, right? This whole thing is called a pan. So that's the root there that I'm linking to is like pencil, spine, pine tree, like that long straight thing, or even the classifier in Chinese for a long straight object, gan. Like these are all cognates with each other, right? This is a very ancient word. So if this is a long straight thing, so pan. This guy, well, here, these guys, these are specifically the, one of them is a mamton, multiple of them is mamtoton. So I've used the like autumn plural, or the like a reduplicative Yudostecan plural. So mam is like a pan northern hemisphere word for hand or fingers. So it's what you're counting with, right? So mamtun is one of these. This one is autumntun. So it's like a personification stone. That's kind of what it means. These are like finger stones, and these are personification stone. So this carries the unit, and this carries the digits. Right? Or yeah, and then so okay, the bolt itself is the pan. The whole thing it's here is a stun. So it's where the tutun are placed. So that prefix is a pan-northern hemisphere stative prefix. So the fact that they exist on here, that's what that means. And we see that in like English stable versus table, or English small versus Russian mal, right? This is the same root, or English steer versus Latin, I think, Taurus. Yeah, same root, but one of them has the prefix s, one of them doesn't. So here, stun, it's this guy. The tray itself is kort. Plural of that is gegel, right? So, and samgan, like the concept, it doesn't have a plural, because if we had a bunch of gegel, it's just a more powerful samgan. So samgan doesn't have a plural, but the tray itself, kort, and that's relating to pan-northern hemisphere for house. It's actually related to gan, which is noted earlier, and pan, which is noted earlier. But it's also, it appears in Greek and Turkic as the word for hand. It's related to like words yurt and garden and guard and gur, like all of these. So like protection or holding or house or something like that. But it's literally like a hand. So like the way that this is structured, it holds these like a hand would hold something. Right? So this term makes sense. Anyway, so here we can manipulate equations here. Oops. I don't remember what that value was. So these are the comparators. I don't have a term for those yet. So this is equals. Here this side is greater than this side. Here this side is greater than this side. And these are chiral, so it doesn't matter if I rotate it, it has the same behavior. So like around the equal sign, like it ends up being the same one on this side and this side of the equal sign. These ones, so here we can go to 40, right? So this will go up to 3, 9. Is that right? No, 1, 3, 9, 27. So total, the maximum magnitude you can get is 40. So that would look like this. So there's a 40 and there's a constant 40. And if we cross the equals, we should flip it over and get its additive inverse. So you could consider this to be positive or black to be positive. It doesn't matter. All that matters is this is the additive inverse of the other one. It doesn't matter which one you choose. If we bring this guy over, he's going to flip over, and we're going to have black 7, red 7, red 40, black 40. Conventionally, I would say black is probably positive and red is negative to be in convention with like the way ancient Chinese numbers were done. These ones here, these long ones, this one isn't finished being painted. It's still got white coat here and I haven't done any dots yet. But these long ones are for higher precision. And let's see, so there's some other things we can do with these. So let's set this guy to 1. Now say we want to take a half. So this is a balanced ternary, so you can't just cut it in half very easily. What you can do though is notice that 1/2 would be a repeating 1 forever. So if we have this so that like our standard orientation for the 0 has the dot facing this way, we can define it so that a dot facing the other way indicates a repeat. And if we pull away, we get this little gap here. We can use that to mark like our decimal point. So here it doesn't matter if it's positive or negative. So now we've got a 1 repeating, like 0.1 repeating forever, so that's a half. Or we could do it this way, 0.1 repeating forever, or we could do it this way, 0.1 repeating forever. So we can use the chirality of this. This is a 0, this is a repeat. We can use this to our advantage to make this number system more effective for us. So let's set that back. And now let's do a simple linear equation. So let's say we've got, what is this? This is 3y. Let's do something like, I don't know, 6x. 3y plus 6x. Sure, why not? Let's do a minus. Still minus 15. Okay, now if I'm not mistaken, 27 minus 9 plus 3, or no, yeah, That's not 15. Whatever this is, we can divide it. Not so good with the balanced ternary yet. Anyway, okay, so generally we're going to want to turn this into a y equals something. So, it doesn't even matter if I understand what this number is. First off, we're going to flip it over, bring it over here. So now we've got the additive inverse of it. Do the same with the x, because we want y equals something. So we'll take this, bring it over. Probably don't need that all the way over there anymore. Just kind of rearrange things. Alright, now we want to divide by 3. Well, we can notice we could just pull this away on all of these. And there you go. So now y equals, this is a negative 2x plus 7. So I guess it was 21. Yeah. There you go. That's the gist of how that works. And we've got some spare parts. If you need to do more refined calculations, there's a much larger one. And there's room for 2 of them on here. We got spare comparators. So you could do, you know, I don't know, say we're doing some crazy stuff. You need multiple. You could make this longer. This is literally just a scrap of wood. And what I did is I cut like roughly 1-inch little pieces of a pencil and just glued them down. Use it like, I use these as spacers. So this is pretty close to, yeah, this side is exact. That bolt length from there, and then I used these to space them as they were gluing so that they ended up straight and they fit these nicely. But yeah, that's the gist. Very simple. You can make it at home. If you want, I can make them and sell them to you. I don't care. Anyway, there you go.